All right, so we're going to continue to work through some questions here. So we're just sketching some circular functions. So it says, sketch the graph of this right here for this domain. Now, the first thing that I notice is that I have a reflection in my y-axis. So I have cos of a negative. But when I have cos of a negative, what I can actually do is rewrite this and just get rid of the negative. So it's just going to be that. So that's the beautiful thing about reflections in the y-axis for cos graphs. You can just ignore the negative. And now we just treat this as normal. So we're going to be finding the amplitude. The amplitude is going to be a half. So that means I'm going to be going a half up and I'm going to be going a half down. Then we're going to find what the period is going to be. The period is going to be 2 pi over. Now here, the what is in front of my x is a half. So it's going to be 4 pi. Then you might want to find the x scale. The x scale is going to be 4 pi divided by 4, which is going to be pi. Now we're just going to draw a normal cos graph. So it's going to be looking like this. Whoops, let's see if we can do that again. That's not the best in the world. Let's see if I can do that a bit nicer. Okay, that's okay, not best. So always make sure that you're drawing it neatly. So remember, it might seem inconsequential as to the neatness of the graph, but VCAR does care very much about the neatness of the graph, and especially about, it should look a bit flat here. So it should look like flat there, then you get a bit curving up. You don't want like sharp turns. So just be careful of that. All right, so what do we know? We know that our period is 4 pi. So this whole thing is going to be 4 pi. And then our x scale is pi. So this is going to be pi. Pi plus pi is 2 pi. 2 pi plus pi is 3 pi. Now, we have to be careful. We have to look at our domain. It's just from 0 to 2 pi. We've gone too far. We should have stopped here. So we can rub out that section of the graph and that and that and that. And this is where it's going to end. So always make sure you're looking at the domain. You don't necessarily have to draw a full cycle. You just look at the domain there. So this is going to be 2 pi negative a half. And that's it. All right, let's go on to our next one here. So we are sketching this. Right, that. So we're going to begin as we normally do. We're going to find what our amplitude is. My amplitude here is going to be 4. So that means I'm going to be going 4 up, and I'm going to be going 4 down. Then I'm going to find what the period is going to be. It's going to be 2 pi over 3. Then I'm also going to find what my x scale is, because that's always useful. So it's going to be 2 pi on 3. Now I'm going to divide it by 4, which is the same thing as timesing it by a quarter, and that's always easy when I'm dealing with fractions. So it's going to be 2 pi on 12, which is the same as pi on 6. Perfect. So just because I got a lot of numbers there, that's my amplitude, that's the period, that's the x scale. Let's now draw in our first cycle here. So it's a sine graph. So I'm going to be going, whoops. I'm going to be going up, then down, then up again. And this right here is going to be, and I might do this in a different color. This is going to be 2 pi on 3, like that. And as you'll notice, I'm not anywhere close to where I need to be. I need to go all the way to 2 pi. So to figure out how many cycles I'm going to have here, I'm going to take that and I'm going to divide it by the period, which is 2 pi on 3. Remember, what we do here is we go 2 pi times, so state change flip. We're going to get that. These are going to cancel, which means I'm just going to get 3 cycles here. Whoa, that's an ugly 3. I'm going to get 3 cycles. So 3 cycles are going to fit into my domain here. So let's draw another 3 cycles, shall we? So it's going to be going up, down. So that is very ugly. Even here it's a bit wonky, but I'm just going to leave it. So remember, and we're going to be very judgmental of your sketching ability in tests. So you're going to have to apologize my poor sketching ability, but you're going to have to draw it nice and neat for us. No excuses. Right, so once I'm here, let's now draw in our other point. So here's one cycle. Here's another cycle. So it's going to be 2 pi plus 2 pi. So it's going to be 4 pi on 3. And then our last one, so here's our last cycle here. This is going to be 6 pi on 3. Now 6 pi on 3, well 6 divided by 3 is just 2. So instead of writing that, I'm just going to write 2 pi, like that. All right, now I need to find my x-intercepts. Now this is where things get a little bit tricky, because what we're going to be doing to do this is using our x scale. So what does that mean? We know our x scale is pi on 6. So we know here, this is going to be pi on 6. This is going to be 2 pi on 6. This is going to be 3 pi on 6. This is going to be 4 pi on 6, which is 2 pi on 3 once you simplify. So 5 pi on 6. This is going to be 6 pi on 6. This is going to be 7 pi on 6. This is going to be 8 pi on 6, which is 4 pi on 3. Then this is going to be 9 pi on 6. This is going to be 10 pi on 6. This is going to be 11 pi on 6. And then finally, this is 12 pi on 6. So as you can see there, I have found my x-intercepts, and I did that just by counting up by my x scale. And when I did that, I was just kind of looking at horror about how uneven all my cycles are here, but let's just leave them. What you also have to make sure is once you've done them, did you notice how I didn't simplify as I was going? Because it's just nice and easy just to keep counting up if you don't simplify. But then you need to go back and say, hey, 2 pi on 6 is pi on 3. And 6 pi on 6 is pi. And 10 pi on 6, oh, where's the pi there? Is going to be 5 pi on 3. 5 pi on 3. Whoops, can I do that in blue? 5 pi on 3. So just make sure that you're simplifying. The ones that we really care about are the x-axis, the x-intercepts. So just make sure you've got those. And that's how you're going to do it. So don't simplify at the beginning. I find that you simplify at the very end. That's the easiest way to go about it. Okay, last one. Now, what makes this one interesting is a few things. First, we have a reflection of the y. And as you can see here, my domain is negative 12 pi to 12 pi. So I'm going backwards as well, which is going to make things a bit interesting. First things first, when I've got this and I've got a negative here, I just take that negative out the front. Whoops. So it's going to be negative 3 sine of x on 3, like that. And then once I've done that, I'm now just going to treat this as normal. So my amplitude here is going to be 3. So that means I'm going to be going 3 up. I'm going to be going 3 down. The period of this thing is going to be 2 pi over 1 on 3, which is 6 pi. And then we can also find the x scale by taking the 6 pi and dividing it by 4. Both of these can be divided by 2, so I'm going to be left with 3 pi on 2 there. We'll see if the x scale provides that much use, but we might be able to do it without it. All right, now what we're going to do is let's just go forwards to start off with. Remember, it's negative as well, so remember that tells us, it's a reflection in the y-axis. But because we can take that out the front here and we've got a negative here, the way I think about it is, hey, this is just going to look like it's reflected in the x-axis. So that means I'm going to be going down, then up, then down. This here is going to be 6 pi. Then we go again. And the reason why we're going again is because I need to get to 12 pi. Can I try that again? I know I'm being pedantic, but your graphs they do need to look good. Oops, I'm going the wrong way. That's nice. I know that I'm a bit off, but let's just pretend that worked. Actually, let me try one more time. I apologize. Let's just stay on the lines here. Perfect. So this is 6 pi, and this is going to be 12 pi. And then I could just halve it to find this one. This is going to be 3 pi, and then this one obviously is going to be 9 pi. So I don't need to use my x scale if I don't want to. That's just the easy way to do it. Now, as you can see, I also have to go backwards. So that's going to be interesting. So let's now try and go backwards now. So it's going to be like this, like that, like this. And then again, let me try again. So again, doing this on paper is a lot easier than doing it on a screen. I'm just giving excuses for my poor drawing. Never give excuses, give results. Oh, I just can't do it. All right, one more time. You know what it should look like. There we go. All right, so that means this is going to be, well, it's just going to be negative 6 pi. And then this is going to be negative 12 pi. And this is going to be negative 3 pi. And this is going to be negative 9 pi. And we're done. So as you can see there, I didn't use my x scale that much. If I wanted to, I could have said this right here is going to be 3 pi on 2. And then 3 pi on 2 plus 3 pi on 2, if I was to plus those together. So I would plus them together to get my next one. And that's going to leave me with 6 pi on 2, which is 3 pi. But because we really just after the x intercepts here, you can just half 6 pi to get 3 pi instead of counting up by that. So yeah, hopefully that makes sense why I didn't use the x scale here. I just did it that way. All right, and I think that's everything I needed to cover there. So it's reflected. I'm going backwards, I'm going forwards. That looks good. All right, so hopefully all that made sense. And you now feel comfortable drawing. So these were just a bit more advanced, just going through a bit more variations. All right, we'll stop the video there. See ya.